Here you are, sir.
Oh, thank you very much. Hey. I am truly honored to be the first to welcome you to Nordic.js. We're going to have a really awesome conference. If you're not familiar with me, my name's Tom. In the United States, I'm best known as an action movie star. Here in Sweden, you may know me better for my work on the JavaScript framework Ember.js. And I want to talk to you all today about web components, the next big thing on the web. So, one thing that you may do, if you haven't heard of web components before, is ask yourself, what is a web component? What are web components? Now, I'm not a computer scientist by trade. I got my Bachelor of Arts in criminology, actually. So when I have to understand complicated things, I tend to fall back to my more liberal arts major. And I like to look at the etymology of words. So to understand web components, the first thing that we have to do is break it down, the word web components, into its constituent parts. So the first one's pretty easy, web. Obviously, this is some kind of technology that we can use in our web browser. The next part was a little bit tricky, COM. Well, I did some Googling, and it turns out this has something to do with serial ports on Windows computers. So what we're dealing with here is some sort of technology for interfacing with serial ports on the web, which will be really useful for all these robots we've been seeing. Actually, that didn't help at all. I actually had to go read the spec. And it turns out that web components are just a really great way to extend the web platform. Previously, we've been shackled with the elements that our friends at the standards bodies and the browser vendors have given us. But isn't it time that we broke free of our shackles and had the freedom to make our own elements, whatever elements that we want, the elements that are most suited to the applications that we're building? And that's all that a web component is. A web component is just a set of APIs for creating custom elements and describing how they look with CSS, how they're structured with HTML, and how they behave with JavaScript. And that's it. So I'd like to talk to you about three things today. The first is what web components are not, because I think there's some misunderstanding on how people think about them. Second, I want to talk about the benefits of components. I'll spend the first part just like telling you why they're terrible, and then I'll redeem myself by telling you why I think they're awesome. And then third, I'm going to show you how to use components today, how to get the benefits of components today. I'll give you a little bit of a spoiler. It's just a pitch for Ember. So sorry for all the Angular fans in the audience. So let's talk about what components are not. And I hear mean not just web components, but any kind of library that gives you component functionality, whatever it may be, whether it's Angular's directives, Ember's components, web components, React's components, YUI has widgets, yeah? Well, it's out of business now, so. So the other day, I was reading Hacker News, I know, and I came across this comment, which says, with React, I don't really see the point of Ember or Angular. They're basically zombie projects now, which was news to me. I didn't know and told me. So I got out my hackernews.gif, and I face-palmed. So I want to pick just a little bit on Polymer, which is a project out of Google. Now, Polymer is really cool. Polymer, I think the Google team did something really awesome, which is that before they started standardizing a lot of the web component stuff, they started writing a JavaScript library to test that out, which is something called a polyfill, which is basically a library that lets you test out standards before they actually exist in the browsers. I like Polymer a lot. It's helped us get our thinking about web components straight and to test out the API before the browser vendors had to start implementing. However, I do want to pick a little bit on one thing that they said in their documentation, which is build anything from a button to a complete application as an encapsulated, reusable element that works across desktop and mobile. Now, this reminds me a little bit of being a kid when I would find something and be like, this is awesome. I want to use this for everything. It feels so good. Then you take a bite of the dandelion and you realize some things are fun in some contexts and not great ideas in other contexts. So this is something called the hype cycle. Maybe you're familiar with it. This is a concept originated by, I believe it was Gartner Research. And I would recommend that before you adopt any new technology, you seriously analyze where on this chart the technology is. Because when you have a new technology and people have not used it in anger, it tends to become an empty vessel that we fill with all of our hopes and dreams. And eventually, that vessel is going to shatter on the floor and spill your hopes and dreams everywhere, and you'll be very sad. So typically what happens is something shifts. There's some shift in the marketplace. For example, very fast, very robust JavaScript engines in browsers allow for things like Backbone, Ember, Angular to exist, whereas before they wouldn't exist because JavaScript was so slow. And now, there's this great new tool, and everyone's going to jump into using it without understanding what the trade-offs are. And again, it becomes that empty vessel full of your hopes and dreams, and then you use it, and you realize, hey, this technology, like any other, has real trade-offs. And as you start to realize that, your emotions towards a project just plummet into what we call the trough of disillusionment. Typically, the symptoms of the trough of disillusionment are every week on Hacker News, there's a very angry blog post about why this technology has failed a company. But eventually, if you power through that, you can start to find workarounds for the downsides, you can start to fix the problems, and eventually you get a solid technology at the plateau of productivity. So I just want you to remember one thing, which is that Backbone and Angular were once the industry darlings. Understand the trade-offs before following the hype. I'll pose for photos now. If anyone would like to take a photo of me, feel free to put this on Twitter or Instagram. This is some quality thought leadership happening right now. Everyone good? You got it? Okay. Don't forget to use these hashtags. I want to see them trending when I get off stage. This is an animated GIF of a corgi eating cabbage. Yeah. Has nothing to do with my presentation. Other than they're just web components. Don't get too excited. I'll leave that there for a second for you to appreciate. So Cassandra says something really interesting, which is that sampling new technologies, frameworks, libraries, et cetera, using the Hello World test, where you go and you sample it. I like to call this like the Pepsi challenge, where the first sip tastes very sweet. But I don't know about many of you, but I can't get to the bottom of a can of Pepsi. It gets too sweet by the bottom of it. So your first impression of a tool is going to be colored by the fact that what you're doing is inherently simple because it's constrained by time. And I think that a lot of people, when they're building their front-end applications, think of it as something like this, where you have an API, like a JSON API, that serves you your models, and then you have something like a controller that manages your app state, and then you have a bunch of UI components, whether they're like jQuery plugins or Angular directives or Ember components or whatever, displaying that backing data. And they think of this as the architecture of their application. But I was reading a blog post by one of the designers at Basecamp, formerly 37 Signals, and this blog post said, you know what, when you're designing the UI of your application, you're designing the UX of your application, flows are just as important to good interfaces as the individual screens. So in other words, people think of MVC as application architecture, but MVC is just one small part of your application. Your app is composed of many MVCs. So this is the notation that they use at Basecamp when they're designing a new feature. In addition to the screens, they also draw out the various interactions between those screens in the app. This is the notation where you have the screen at the top and then the various actions that can take you to a different screen notated below. So really, if you think about your app, your application state is several shared models, and each individual screen has its own particular state and its own particular set of components. And managing this with existing tools can be very difficult. And I think that people want to simplify it to the point where the solutions are perhaps too simplistic. So to pick on Polymer again for a moment, Polymer says the philosophy that everything is an element is core to understanding Polymer. React says React is an extremely simple concept because it just describes the DOM with components, and components communicate along the DOM structure. But the question then is, how do you manage which components are shown when? How do you answer the question of how the flows in your application are managed? Something needs to be responsible not just for creating those components and wiring them up, but transitioning between them and transitioning back to them. So for example, if you have a triangle, a disclosure triangle, and the user clicks on that, or they make a selection in a list, it's going to be very annoying to them if they navigate back to that page that they were on a second ago and that state is lost. So you really need some kind of holistic system for managing the entire state of the application. You need something that manages the flow of your app so that as you move between these screens, the user isn't frustrated when the state that they were seeing before gets lost, as demonstrated by this GIF. You don't want state flying all over your application. And that's why things like React have to introduce patterns like Flux, because component architecture by itself is not enough. You need something managing which of those components are on screen. And in Ember, we believe that URLs are the solution. We believe that URLs are the killer feature of the web over native. And so you can derive this state of your application from the URL. Think about how powerful the URL is. You can share it, you can bookmark it, and most importantly, it becomes the thing that manages this component hierarchy in your application. And that means it's basically the serialized component state and application state. That's a very powerful thing, and that's something, I think, a fundamental strength that the web has over native. And if we decouple our application state from the URL, we tend to build apps that feel very broken. In Ember, the router is the core of how all of this is managed, about how the component hierarchy is created and how those components are fed model data. So don't think of your application like this as just a series of components. Think of it as a more holistic thing. So now I want to talk a little bit about the benefit of components. So I kind of talked a little bit about the limitations because I think we were hitting peak inflated expectations. But web components are really awesome for a number of reasons. Like functions, I think in JavaScript, they're reusable and they're isolated, so they're inherently composable. And they also give us a very concise syntax for setting them up. So if any of you have used a jQuery plugin before, in your JavaScript, you have to go put the markup in the HTML, and then you have to go write some JavaScript that gets that element and calls the setup, like jQuery.button, right? So this gives us a declarative way of configuring our components. And they're also eminently shareable, I think, which is really great. This is my favorite GIF on the internet, which is Oprah's bees. Yeah, all right. It's Friday, so. And I think the most important thing to me about web components is that they explain the features of the platform. So if you're not familiar with the idea of the Extensible Web, I would recommend that you check out the Extensible Web Manifesto, extensiblewebmanifesto.org. And the Extensible Web Manifesto says that it is the job of the standards bodies to give us features that expose low-level capabilities that explain existing features, such as HTML and CSS, allowing authors to understand and replicate them. So data-bound elements, if you think about it, the input tag is the OG data-bound element, or the A tag. Like if you go in the inspector and you remove an href attribute from an A tag, how it looks and behaves in the browser changes automatically. We've had data-bound elements since the 90s, but we've never before had a way to patch into that as library vendors or as framework vendors as first-class citizens. We've always had to hack things in on top. So the point of the Extensible Web Manifesto is simply to say to the standards bodies, give us, as framework and library authors, the ability to add the same features that you as browser vendors can add. They also help us bridge imperative and declarative systems. So I'll give you an example. This is from an app that I work on called Skylight. And what's cool about Skylight is that each of these things that you see on screen is a component wrapping D3. And D3, if you've used it, is a fairly imperative system. But if you watch this, as the user interacts with one component, all of the rest of the components react to that instantaneously, but none of these components know about one another, which I think is really cool. They're bound together through the model data, and if one component changes something to do with the model, all of those more imperative drawing, all that imperative drawing code updates automatically. And I think this is a very scalable way to work on applications because you don't have the tight coupling that you would traditionally have if you were writing this using something like, for example, jQuery. And lastly, interoperability. I think it's frustrating for all of us that we have these silos or these walled gardens in our ecosystem. So if you buy into Angular, for example, you lose out on all the components that people are writing for Ember, and vice versa. And I think a good counterexample to this is the Promises A+ spec that Dominic DeNicola worked on. And there were actually some surprising effects that came out of having this interoperable way of dealing with asynchronous data. So it started with different promise libraries at the bottom, and basically said, you know, they've got Q, which is a promise library, but it was way too big for us to embed in Ember, and we really needed promises in Ember. So we wrote a library called RSVP, which was a very small subset of the functionality. And someone else came along and said, well, we're going to write Sparrow, which is like RSVP, but faster. And all that meant was that we have these competing implementations of the same functionality. And then those were encapsulated by Promises A+. But out of that common shared functionality, we now have promises in the DOM. And all of these things can interoperate. So now we've got promises actually part of the JavaScript specification. And then once you've got those promises everywhere, when they become ubiquitous, you can start using tools that can put them together. So for example, Q and RSVP have a helper called all, which builds a promise when all of the input promises have resolved. Or you can say any, when any of these promises have resolve this other promise. And it doesn't matter where the promises come from, whether it's Angular, Ember, RSVP, Q, Sparrow, because they behave the same way, they're interoperable with whatever tools that you're using. And then, because they become so pervasive and ubiquitous, they can actually start to be built into the language. So TC39 is right now working on syntax for something called an async function, which is a function that just returns a promise. So you can start writing code that looks totally synchronous, but under the hood, it's all async using promises. And I think if you tried to design the async function up front, it wouldn't have gone anywhere. It would be too complex. But by starting at the primitives as a community and building up, we get some very powerful features in the language. And to me, that is the benefit of something like the Extensible Web Manifesto. It lets us experiment as a community. So we can bridge these ecosystems. I would really love it if Ember and Angular could share components and directives. And so I hope my colleagues who work on these other frameworks and libraries will help us adopt. This is the proposal we've been working on, which is just elements will have a bind method on them. And bind takes the name of a property, and then it also takes something called a path observer, which if you use streams in Node is very similar. It's basically just the idea of, it's like a stream that gives you a new value every time that changes. I won't go into that too much. So let's talk about using components today. And I'm sure you're not surprised to learn that this is just me giving you a sales pitch for Ember. Fortunately, I don't make any money for it, so I don't have to feel too icky. So there's two reasons why I think using components in Ember are pretty cool. The first one is that it's super easy. It's really easy to get started. It's just a few commands. The second thing is, I don't know if you guys have noticed this, but while you guys were using all the hip frameworks, we've been building some really freaking awesome tooling around it. And this leads me to my next thought leadership point. An okay solution with great tooling will beat a great solution with poor tooling every time. The tools that you have around the solution are just as important. So things like distribution, things like debugging, are just as important as the solution itself. So let me give you a quick demo. I think some people, I was so nervous. I was in the speakers lounge. Some of the other speakers were talking about how risky it is to do live coding. Guess what I'm going to do right now? All right, so let me switch over to merging. To mirroring. Oh, wrong way. All right, there we go, boom. Can you guys see that okay? Sick. Okay. Okay, so let me make a new project. So I've installed, there's an NPM module called Ember CLI, Ember-CLI, so I've already installed that. So I'm going to initialize a new project called Nordic.js. So what this will do is automatically create a project, an Ember app for you. It'll lay it out the way that we want you to lay out your files, so you don't have to spend 2 weeks arguing with your team about what kind of file layout you want to use, which is a huge productivity boost. And then we'll automatically install all of the dependencies using NPM and Bower. And let's just hope that our conference Wi-Fi stays up. All right, done. So let me CD into this now. And I'll go ahead and open this up in Vim. Is that big enough? Douglas Crockford, can you see that? Are you in the back? That's an old guy joke. Sorry, Doug. Sorry, is it too soon? Okay, so then I'm just going to generate a new component. So I'm going to build a little app for looking at GitHub contributors. So I want to create a GitHub user component. So to do that, I'm just going to say Ember G component. And I will say, let's call this GitHub user. So if you're familiar with Rails, it's kind of a similar feel, although of course Ember is a much different project than Rails. But you can see that it's automatically for us generated a handlebars template, a JavaScript implementation to control its behavior, and a unit test that we can use to write tests as we go. So now, I'm going to switch back to our code, and I'm just going to do a little test. So if I open templates, you can see I have a component called GitHub user. I'll just put in hello world here. And then we'll go to our application template, and we'll just use that component. And to use the component, all we have to do is say the name of it, which is GitHub-user. And now we'll just hit localhost 4200. Oh, I didn't start the server. I'll start the server with Ember server. I like how this microphone picks up all my heavy breathing. Feels like a creepy phone call. Okay, so you can see that our hello world is there. And now if we change it, let's say we'll put in an H1. We've got auto reload working here. And now you can see it's wrapped in an H1. So automatically updates as I type. This looks a little bit ugly. So I'm going to install there's a module for Ember CLI that will give us bootstrap styling. So let me install that now. So this it figures out is in Bower. It downloads all the CSS and the JavaScript for us. now, oh, let me start the server again. Sweet, okay, so now we've installed 300 kilobytes of dependencies to display in Helvetica instead of Times. So we're well on our way to being a front-end engineer. So I'll show you just a couple more things. So the first is that we can pass in information here. So in our application handlebars, you can see I've got our component here, GitHub user. Let's say I want to provide a username. So we'll say, let's say username. I'll say Tom Dale. I'll put mine in right now. So here you can see that this GitHub username is taking a property. It's receiving a property from the parent template called username. Now to use that in my template, all I have to do is open this up and say something like, hi, username. And now if we refresh, you can see that it's passed it in. And so what's cool about components is they're totally isolated. So by default, they don't have access to the state of your application. Only what you explicitly pass in gets displayed. So you have to be really explicit about those dependencies, which means that you end up writing components that are very loosely coupled. Now let's get some data into the system. So I'm going to generate a new route. And in Ember, like I said, everything is tied into the URL. The way that the components and everything are set up is all driven through the router. So I'm going to say ember-g route. Let's call this contributors. And this is going to automatically create a route and a template that goes with that route. And it's also automatically added an entry in our router DSL so that we can hit this URL/contributors. So now I'll say contributors here. And if I refresh the page, it obviously doesn't say that, but if I hit /contributors, you can see that it goes to that page. And our back button and our forward button and everything work because we are building a URL-driven app. So let me just go grab the model data from GitHub. Integrating with an API is as simple as using promises, because Ember is instrumented up and down using promises for async behavior. So in this case, because I want to specify the model for a route, I'll just create a new function called model. And I'll just return a $.getJSON. I've got the URL here. So this is just using the public GitHub API. And this will return an array. So in our contributors template, we can just loop over this array using #each. And we'll just pass in, inside the each, we'll use our component. And we will set its title to, let's see, the property name in the JSON is login. So we're just going to take this from the JSON that we get back from the server, and we're going to put it into our component. Okay, so now, when this reloads, yeah, worked the first time. So you can see it's pulling that list of users from the GitHub API, and now it's creating a component for each one, but they're totally isolated. And I think what's cool, I was talking a little bit about the infrastructure here. So if you haven't had a chance to check out the Ember Inspector yet, I'd really recommend you check it out. It's awesome. You can get so productive with it because it lets you understand exactly what's going on in your app. So I'll come to the view tree here just as an example. I can click this components checkbox, and it will show me all of the components in our app. As you hover over them, it shows you where they are on the screen. And I can click on any one of these and bring it up here. And these are all data bound. So you can see I have this property called username. I'll just change Peter's here, the second one, Wagonet. I'll change that to YCats. And you can see it live updates. This is super useful for development. And I think what's also really cool about it is that you can play around with this inspector on any production public website that's using Ember. So for example, if you go to Vine, hopefully this is safe for conference, because you never know on Vine what you're going to get. But any public Ember website, like Vine, for example, you can pull this up and you can actually see how they're using components in production. So that you can see that Vine, for example, has an autocomplete widget, which is really cool. But it's not just the inspector, it's also the distribution. The tool that I'm using here, Ember CLI, is we're building it to be kind of a top-to-bottom solution for deploying, building, managing dependencies. The fact that every team, I guarantee you, if you switch jobs in the next year, you're going to go to a team that has their own set of cobbled-together solutions. But it's silly. We all have the same problems. We should have shared solutions. So one of the big problems is you see a cool plugin on Hacker News or wherever you want to use it. Just like I did with Twitter Bootstrap, you can also install individual plugins, components. So here I'm going to say npm install ember CLI spin.js. And just by running this one npm install, it's now given me a component from npm that I can use in my Ember app. So let me just go to our application template here. So let's go in here, and I'll just use this Ember Spinner app component. Oh, it's rebuilding. Of course, it's always the last one that fails. Ah, there it is. Sweet. Awesome. So you can see with one npm install, I've already downloaded this component, and I think your mind can kind of extrapolate what would my development workflow be like if I could just go browse the web for some cool components that have been built, not just for Ember, but web components, Angular directives, install them with one npm command, and then boom, start using them in my app right away. I think you can see this would be a huge productivity booster. So using components in Ember, super easy today. And we've got amazing tooling that'll make you really productive with it. And you have to wait for the developer tools to catch up with things like web components. So if you're interested in what I've talked about, emberjs.com/guide/components, we've got full documentation for it. And with that, thank you guys very much.